Okay, this is the chi-squared analysis. And just to kind of frame this a little bit, is the chi-squared is considered a non-parametric test. And essentially what that means is normalcy of distribution does not have to be, it can be violated, and you can still do a chi-squared analysis using inferential statistics. So that being said, what I'm going to do here is we're going to go to page 517 in the text, question 4. And what's going on here is that you have this manufacturing company, Benson Manufacturing, and they have 3 suppliers, and you're trying to evaluate the proportion of defective components for the suppliers. And so you've taken 500 examples from each of the suppliers, and you've calculated this good, or the defective and good, for each of these suppliers. And what you did was you took all these numbers here and you put them into some type of software, and you've come up with, this is the actual output. And this one is from Minitab. It would look very similar if you ran it through SPSS or R or any other statistical software package that is out there. It'd all come up with something very, very similar looking to what you have here. And so it's a chi-squared test, supplier A, supplier B, supplier C. And as you'll see, here are each of those suppliers. And here was the 15, the 20, and the 40, which matches back to the 15, the 20, and the 40 for defective for each one of those. And then the good is just adding it up to 500 down each of the respective columns. And then the other thing you've done here is the computer's calculated this for you, but essentially you've done what was the normal fair share, or what would be the expected fair share, the expected value for each of these suppliers in each of the defective and good. So you'll see here that you have 1,500 was the total, and so it's 500, 500, and 500. And the percentage good is exactly 95%. So 95% of 500 is 475, 475, 475, and the balance is 5%, and that's 25, 25, and 25. So this is considered what you would expect to have happen, all things being equal. And then we'll talk about this one down here a little bit later. And this is more or less the key part of the evaluation, or the analysis, a chi-squared analysis. Now you'd ask yourself, what is an appropriate research question? Well, clearly you want to determine, is there a difference between the proportion of defective rates for each of these suppliers? Very reasonable, appropriate research question. So now you would want to ask yourself, what is the appropriate null hypothesis? Well, the null hypothesis always includes equality. And in this case, you just want to find out, are they the same or are they different? And so your null hypothesis would be each of these proportions is the same. These would actually be A, B, and C for suppliers would all be the same. The alternate hypothesis is just the opposite. The proportion of A is not equal to the proportion of B, is not equal to the proportion of C for each of these for the good categories. Which is the dependent variable and which is the independent variable? As we've talked before, the independent variable drives the dependent variable. It doesn't usually work the other way around. So in this case, you would ask yourself a question in general. Does the supplier drive whether it's a defective or not, or does whether or not they're defective determine whether they're a supplier A, B, or C? And so it would be, for the most part, I mean, you could make a case the other way, but for the most part, the supplier drives the defective rate. And so you would say that the dependent variable, which is the outcome variable, is the defective or not defective, and in this case good, And the independent variables are the suppliers. And you have three of those, suppliers A, B, and C. At what significance level would you conduct the test? It was given in the textbook as P.05, but if it were not given, you would naturally just default to P.05. But we're going to run this at a P.05. Okay, before we get to the results, I want to kind of create a hook back to where we came from, just so you know what's going on here. And this is pretty much exactly what we've done before. We've done our distribution. And we'll take off for artistic as always. And you have this chi-squared curve, right? And chi-squared never goes below 0, by the way. And so you have the do not reject, HO, and you have the reject, HO. And then you have to come up with your critical value here. Now the critical value here is determined a little bit different. It's not based upon the sample size. It's based upon how many independent variables you have minus 1. So in this case, you have 3 independent or values for your independent variables. You have 3, A, B, and C, and then minus 1. So your degrees of freedom is 2. And this is an excerpt from the chart in the back of the text. And so degrees of freedom of 2, and you're running at a P.05, excuse me, P.05, you would get a critical value on a chi-squared scale of 5.991. And then the computer is going to, the computer, fortunately, has calculated for you what the chi-squared value is, 14.737. And you see that clearly it falls way out here in the reject zone. So you would expect that the p-value would be something very, very much less than P.01, which is precisely what is demonstrated here. So you have chi-squared, 14.737. Degrees of freedom is 2. Don't worry about that. But always, 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 as soon as you get one of these printouts, look for the p-value, and that will tell you whether there's something going on or not. And in this case, the p-value is much less than P.05, which you would expect because, remember, your chi-squared value is way out here, so you'd expect that p-value to be something close to almost 100%. Indeed, that is the case. Now we go in here and we say, okay, we did the significant. Would you accept or reject? You would reject the null. Would you accept the alternate? Yes. Which supplier has the lowest proportion of defects? Now, once you've decided that there's something going on in here, you can go in here and just analyze all these numbers however you really want. So clearly, the supplier with the lowest defective rate for the actual, not the expected, but for the actual is 15 divided by 500. So supplier A, because this is 20, and supplier C is 2 to 3 times the rate of A and B. So something is clearly going on there, and their defective rate, as you might expect, is 40 on the observed, and what you were anticipating was 25. So there's a pretty good sized gap between what they should have gotten and what they actually received. And this is another indicator. It's kind of a subtlety of a chi-squared analysis, but you have 4, 1, 9. And so the higher this number, the more variation, or the more change or difference you're going to get between the expected and the observed. And so if you took all these, the 4, the 1, the 9, and all of this, and added them up, it'd actually come up to 14.737. So you can actually figure out what relative contribution each one of these has, but that's kind of immaterial in some respects. Okay. Which supplier came closest to the expected outcome for testing good? As you would anticipate, 475 is what was expected, and they actually came in dangerously close here. However, these guys, supplier B, came in much closer. Even though their defective rate was a little bit higher, they came in closer to what was expected of them. And that might have some business implications, because you'd say, hey, I don't want a part that's too good. I just want the part that is defective at the rate at which we need it to be. So now the final piece is, what are the business implications for recommendations associated with this this situation? And you go back to your original research question, and the research question we're trying to figure out was, is there a difference between these three suppliers? We determined that it absolutely is correct, and in fact, or that absolutely would be the case. And in fact, we determined that the defective rate for supplier C was 2 to 3 times the other two, and it was well off what was expected. So you could make a potential business recommendation here that at a 95% confidence level, that the proportion of defective parts for supplier C under a chi-squared analysis was significantly higher than what was expected, and 2 to 3 times higher than the proportions that were shown for supplier A and B. So therefore, you would have a couple of choices. If everybody was providing the same part, you might get rid of supplier C. If you want supplier C in there because they've got a nice price or a good price, you might want to coach them a little bit to see if they can create a little higher quality at the same price that they're providing you. So there's a lot of different business implications and recommendations that you can make here, and I'll leave that up to you as you are going into the exam and then on into the real world, how you would analyze that for certain. That concludes the chi-squared analysis. Thank you.